Good afternoon, everyone. My name is Meghana, and today I'll be talking about some of the work I did during an Outreachy internship a year back, specifically refactoring Backlight and SPI helpers in tinydrm. So this is the outline for today's presentation. It'll be a brief presentation. I'll start by introducing myself, followed with an introduction to the project, followed by the actual work that I did with respect to the backlight and SPI, and finally I will conclude. So about me, I was around 15, Outreachy intern. So this was a 3-month internship from December 2017 to February 2018. So it's been a while. And I was mentored by Daniel, Sean, and Noralf to contribute to the DRM subsystem. So the project goals were to refactor the backlight and SPI helpers in tinydrm, and specifically to make the helpers less tinydrm specific and make them generic so that they can be used by other drivers. So I'll start off by introducing DRM. I'm pretty sure most of you know this already, but I'll just spend a slide on it for completeness sake. So DRM stands for Direct Rendering Manager. It's a subsystem of the Linux kernel and exposes an API that user space programs can use to send commands and data to the GPU. It came about to address limitations of FPDev, specifically to be able to handle modern 3D accelerated GPU-based video hardware. So this is just a diagram. At the lowest level, you have hardware, CPU, RAM, etc. And then you have the Linux kernel, and the DRM subsystem lies in between the Linux kernel and other applications. So what is tinydrm? So tinydrm, as the name suggests, consists of DRM drivers that are so small that they can fit in a single source file. And they contain helpers for very simple display hardware, such as LCD displays for the Raspberry Pi. So it contains helpers for the MyPi display bus interface, and specifically, there are 3 implementation types, which I won't really go into the details of because it's not very relevant. So this is just how the source code is. This is just a very basic black box view of how the source code is organized. So you have the tinydrm core, which contains the helper functions, the pipe, and tinydrm core.c. And then you have the tinydrm drivers, the actual drivers, which will utilize this, the code in the core. And so specifically, the thing which I will refactor are some of the tinydrm helper functions. And so specifically, the task is to refactor and move these helper functions from the tinydrm helpers to general DRM source code files so that they can be used by other drivers. I'll start by explaining some of the refactoring work I did for the backlight. So previously, there were helpers which were present in tinydrm to find, enable, and disable the backlight. So the task which I was working on is, so Backlight is used by other drivers in the DRM as well, not just for, it's not used by just simple hardware. It's used by, it's not used by, it's not just used by simple kind of drivers. It's used by other drivers as well. So can we make these helpers more general? And can we move them to video backlight so that they can be used by the other drivers and not just the tinydrm drivers? So during this process, I found that there was quite a bit of replicated code and different ways to enable and disable a backlight. So there were different combinations of flags which were used to enable and disable them. So I tried to clean this up in a few places and made it more modular by encapsulating it into backlight enable and backlight disable functions. So specifically, then is what was present before, and now is what was present after my some of the changes that I made during my internship. So previously, as you can see, wherever you wanted to enable a backlight, you'd always have to check and check for these flags. So now, instead of having to do instead of having these 3 lines of code repeat everywhere, I encapsulated this in a backlight underscore enable function. And so it's less lines of code, easier to use, more modular. The next thing is, as I had mentioned before, try to make this more general so they can be used by other drivers. So specifically, we had tinydrm of find backlight. So we moved this function from tinydrm helpers to the video backlight, so they can be used by other. So this function can be used by other drivers as well. So the second thing I worked on is some of the helpers for SPI. So the SPI is an interface bus to send data between microcontrollers and small peripherals. And in tinydrm, there were helpers for device drivers to communicate with the SPI core. So the goal, as I had mentioned, the goal as part of the goal for SPI is kind of fits in my overall goal of refactoring. So the thing which I wanted to do was to remove redundant chunk splitting in the tinydrm SPI helpers. So what is this exactly? So consider DMA transfers directly between the SPI hardware and a memory buffer. So the problem is, say we wanna be able to send large or greater than 64 kilobyte buffers in one go to SPI. But tinydrm, the helpers present in tinydrm split the buffer into chunks which were like less than 64 kilobytes because in one of the tinydrm drivers there is an upper bound check on the DMA transfer length. So we want to remove this splitting in the SPI helpers because the SPI core does this anyway. The SPI core splits the messages, but the problem was that before the message goes to SPI core, there was a check in the driver to see if it's less than 64 kilobytes. So what I did was remove chunk splitting in the tinydrm SPI transfer and split the buffer in the driver itself, the driver side code. And the SPI core splits the buffer into chunks anyway, and remove the upper bound check in BCM 2835, which is the driver code. So this is just, okay, so this is one of the patches where I removed DMA length checking in the driver side code. And here is an example of where I split into less than 64 kilobyte chunks within the driver PCM 2835 code. So the current state, or like post my internship, was that the backlight patches have been accepted, but the SPI patches were still being discussed because there were also some other issues where there were some warnings and errors, and like so I had to change some code in SPI.c to reduce the buffer size to even less than 32 kilobytes because it gave me some errors. So that was still under discussion and wasn't yet accepted. So in conclusion, I refactored backlight helpers and tried to with the SPI helpers. I learned a lot about the Linux kernel and learned to collaborate with people and learn how to communicate better, I guess. So questions?
Is it working? Okay. Okay, I'll also talk about DRM stuff later on Friday, but what is the kind of the most, what should I say, the time-consuming part of DRM development? Because, you know, one of the problems I personally have, maybe it's not, you may not have this issue, is you usually have to just build the entire kernel. I really hate doing that, like Linux kernel. Have you had to go through that, or do you have some kind
Yeah,
of
that
like
was
shortcuts?
so that was also an issue, and I think I had spent a couple of weeks just trying to set things up on the hardware, so that took a lot of time, more time than expected, because I expected, yeah, within the first couple of days I'd be able to compile the kernel, etc., on the hardware, but then there were issues with the hardware, setting up the hardware, so yeah, that was an initial barrier, yeah. Um,
So I will follow up a little bit one more
Sure.
time. Like is like compiling the code and also like doing another iteration if you have to make a fix. Is that like a kind of a limiter in a sense in the development cycle? Because it is to me to some extent.
It is, but I don't see another way around. I mean, if there was a way around it, that would be good, but I see it as an inevitable part of the sector.